Alright guys, welcome on back. So this video is going to be our intro to factoring video, and this is going to piggyback off of that 6-minute video that I posted, I think like yesterday or maybe a day back, something like that. That was just where if you have a graph, alright, your solutions to that function are just your x-intercepts. Alright, for those of you that didn't watch it, feel free to go back. It is just a 6-minute video. Maybe I'll edit it into this one to intro this one. No, I'm just going to leave it as is, so feel free to take a look at that last one, okay? And thus far, what we've been working with are a lot of problems that look like this, that f of x is equal to ax squared plus bx plus c. This entire function here is perfectly accurate, but what you've got is a situation where you've got f of x equals, or y equals, whatever you want to call it. The difference here is that now we're going to have it all equal to some number here. Ideally 0. If it's not 0, you do a couple of things to it, or, it's a different kind of problem. But the point is, it's going to be equal to a number over here on the left or right, on the other side of the equal sign. To factor out is actually pretty easy. All you have to know is factors of, multiplication, division, that kind of thing. If you know what numbers go into other numbers, you will be good. Okay? So, here are the things you have to do. You have to start... Oh, my marker is dying. Give me 1 second. So you have to start with your numbers. So start with your numbers. And work alphabetically, okay? And work alphabetically. This will all make more sense once I actually start doing it. But you're just going to start with your numbers and work alphabetically. Alright, and I'm going to go ahead and do most of my problems today in purple. Brown will stand out better. Alright, so what you're going to do is, again, we're going to start with our numbers. You'll notice that we have a 16 x squared, I don't know, plus 8x equals 0. Alright, and you'll notice in brown here I've got 16 and 8. We want to start off with our numbers, and all you're going to ask yourself is what number goes into both 16 and 8. Ideally, you want to pick the biggest number that goes into both of these, but you could just start with 2 and slowly take these out. Like I said, you'd want to factor these out. So what are all their factors? You do not have to go through this process. I'm just going to show you one way to label all of your factors. Like, I already know that 8 goes into 16 and 8 goes into 8, so I know that's the one that I want to use, and that's the one I'm going to use at the end here. But just in case you're not sure how to get to that, here's how you do it. This is 1 times 8. This is 1 times 16. This is 2 times 8. This is 2 times 4. 4. This is also 4 times 2, technically. I'm not going to write that. Let's see. And then that's it for these factors over here. But over here I have more. Instead of just 2 times 8, I also have 4 times 4. Alright? So you'll notice we want to look for the largest factors. And you'll see that the ones that we have in common are 1, 2, 4, and 8. The biggest number that they have in common is that 8. So I'm going to pull out an 8 from each of these. Okay? And whatever I factor out, I'm going to go ahead and factor out in, I don't know, green, because I've already circled them in green, so it'll work. Alright? Let me go ahead and pull out now. So we just agreed that 8 is the biggest number that goes in both 8 and 16. So you're going to put this 8 outside of your parentheses. Alright? You're going to put that 8 outside of your parentheses. So here's your parentheses. Alright, so we pulled out 8 from both of these. Awesome, that works. Now, what I meant by alphabetically is that this could have any number of letters. This could be like X, Y, Z, A, B, C. It doesn't really matter. I recommend you work them alphabetically. That way you know when you're done with something. Does it really matter what order you do the letters in? No, God no. You can do whatever you want. But I would recommend it in alphabetical, at least until you're comfortable. Okay, so what you're going to do is you're going to look at your two exponents. We have x squared and x. Just like earlier, we looked at our two numbers. We're going to look at our two letters. All right, they're x squared and x. The only thing that differs is this exponent. Sometimes that'll be the same. What you're looking for is the common factor. And how you find that is you're going to find the letter with the lowest degree. Remember, degree just means that exponent value. Okay, so you have x to the second and x to the first. Which one has a lower degree? X to the first, and I'm going to go ahead and write that little 1. X to the first has a lower degree, so you get to pull out 1x to the first. Again, you do not have to write that little 1 up there. I'm just doing it to make a point. All right? And then technically we would go with all of our other letters. This example doesn't have anymore. So next I would go with like Y's, next I would go with Z's, etc., etc. All right. But once you've done all of your letters and all your numbers, you're done factoring out your common factor. Now we just have to find out what goes back in this parentheses here. So to find out what goes back in our parentheses, again, in brown, we had 16 over on this left one. And, I'm going to do this one by one. Again, you can do this rather quickly, but I recommend that you go step by step in order first. Start from left, go right. All right, so this 16, we pulled out this green 8 over here, okay? So from 16, we pulled out 8. When you when you divide 16 by 8, what do you get? You get 2. All right? We had an x squared. We pulled out one of the x's. So x squared divided by x, what's left over? You have 1x left over. Okay? And then we're going to do the same thing for the next number and, just bring down your sign so that plus sign still comes down. All right, don't lose your sign. And we're going to try with 8. So 8, I pulled out an 8 over here. So from 8, I pulled out 8. What is 8 divided by 8? Hopefully you guys know by now. That's going to be 1. And again, I'm going to write the 1 just for example purposes. And then here's your x to the first. You pulled out an x to the first. So x divided by x just gives you 1. You could say that this is times 1 if it really helps. So I'll go ahead and write out that step. But x pulling out x just means you wouldn't have to write it. You would have just left it as 1. So your final answer here should look like this. 8x times 2x plus 1. All right, and that's your, oops, sorry, let me get that on screen. Sorry, guys. All right, there you go. So that would be your answer here. 8x multiplied by, in parentheses, 2x plus 1. Again, your steps were really, really simple. You're just going to pull out your common factors, start with your numbers, okay, whatever your greatest common factor is, and then go with your letters. Again, you're going to pick the one with the lowest degree. X to the second, x to the first, you pull out x to the first. From then on, it's just a matter of dividing. 16 divided by 8 is 2. 8 divided by 8 is 1. X squared divided by x is x. X divided by x is just 1, so you wouldn't have to write it, which is why we ended up here. All right? And that's factoring out a greatest common factor. Hopefully that made sense, and hopefully it doesn't throw anybody off. This will happen a couple of times. It'll happen a lot in your practice and your homework and whatnot. But this is the most basic form of factoring, and it's something that you really shouldn't be new to. It's something you've probably done before. It is really just dividing. Okay? So, oh yeah. So I'm going to go ahead and get all this on screen. And you're welcome to pause it here. Feel free to copy down the example and check it out. I'm going to go ahead and move on to the next page right now. So here we go. Now there are two things that I do want to introduce. And I've actually already introduced this to you guys earlier, and I told you guys it would be useful. It's going to come back again. So there are two of these things. The difference of perfect squares. Difference, I think this is my dying marker. I really need to not use this one. Difference of perfect squares. Squares. All right. And then we're also going to introduce how to deal with the just perfect squares. Okay, so let's start with the difference of perfect squares. If you guys remember, I taught you guys this during FOIL, where I said that if you have let's see, in brown, x plus 1, that's a 1, well, whatever, and then x minus 1, you have the same values, all right, x and 1 in both parentheses. The only thing that differs is that plus or minus sign. In fact, I should have done those in different colors, so there. Oh, that didn't work at all. Anyway, so x plus 1, x minus 1, the only thing that differs are the signs in the middle. And what you do here is when you do FOIL, your outer and inner terms are actually going to cancel out, so you don't have to worry about them, and you can just do your first and last. So x times x is x squared, and then 1 times negative 1 is minus 1. Pretty simple. You guys already did this in FOIL. Well, the difference of perfect squares when factoring is to be able to recognize when this happens. So, in an example, let's see. I'll do it in blue. So in a given example, all right, if I gave you a problem like, we already did this one, I'm going to go with like x squared minus 64. And I ask you to factor this. So the problem would say like factor completely or something like that. Factor completely or just factor, who knows. But those will be your instructions. All right? And when you're asked to do that, what you have to notice is that A, this is a binomial. It's a little bit different. Oh, this will be, I'm sorry, equals 0 or something like that. But what you're going to notice is that this has a binomial separated by a minus sign with two perfect squares. Okay, your first flag should be like, hey, I have a binomial, because most of your problems will look like the one that you just did. It'll have that ax squared plus bx plus c. In this case, there is no c, but you know it would be in that format typically. But then suddenly you see that you have this binomial. You do have that ax squared, and then it skips right over to c. Okay, this should be a big flag for you. As soon as you see any binomial, really, it should be a big flag, and you should start looking for perfect squares. And you'll notice that x squared is a perfect square just because all letters squared are perfect squares. And then 64. What's the square root of 64? And hopefully you'll remember that the square root of 64 is 8. Okay, so 8 times 8 equals 64. And that's what you're looking for, really. You're looking at this value here, and you're asking yourself whether or not this is a perfect square. So can anything multiplied by itself equal this? 25, 16, 36, 49. I think I skipped one somewhere in there. Anyway, the point is, if it's a perfect square, you're all good. Perfect squares, by the way, in case you guys haven't remembered from the exponents lessons, is just any number that multiplies by itself, and you'll get another number. 5 times 5, 10 times 10, 3 times 3, doesn't matter. Any of those, all right? And this is going to be the reverse of that, okay? So if you see this difference of perfect squares, all you're going to do is you're going to split it up into the square root of each value. So let's go ahead and expand this a little bit. I'm just writing it a little bigger so I can add things in. All right, 64. And what you're going to do is you're going to take the square root of each value. All right, what's the square root of x squared? Remember, your radical and your square here will cancel out. The square root of something squared is just whatever's underneath, in this case an x. All right, so you get an x, which I will draw in purple. So the square root of x squared is x, and the square root of 64 is 8. And what you're going to do with these two numbers is you're going to write them twice. Or not numbers, I'm sorry, one's a letter. Write them twice. Put parentheses around them. The only difference is that just like you did before, remember one of them has a plus sign, one of them has a minus sign. Plus sign, oh wait, I'm so sorry. Plus sign, and then minus sign. I don't know why I'm making so many mistakes, I've already done this once. Anyway, that is how you deal with a difference of perfect squares. Okay? It's just the same as you did with FOIL, except now we're going backwards. In fact, factoring is literally the opposite of FOIL. So everything that you've learned how to do with FOIL, we're going backwards now. Instead of going from parentheses to something simplified like this, you're going from this to break it out in parentheses. I promise that there's a purpose for this. It helps with dividing and whatnot later on. We haven't gotten there quite yet, but I promise that this has a purpose and it'll actually make your life a lot easier with upper level math. Okay? So this is how to deal with this problem. Hopefully we don't have any questions. Hopefully everyone is good with that. Alright? So, next we want to deal with perfect square trinomials. Alright, so that's difference of perfect squares. That's all on screen. Feel free to pause. Perfect square trinomials. Alright, where's my marker that works? Perfect square trinomials. So in your book, they actually go in the opposite order. Oh god, this is fading. This is probably the bad marker. Anyway, they go in the opposite order. They actually introduce this one before they introduce difference of perfect squares. But I already told you guys the difference of perfect squares one, so I didn't really want to start with the unknown one. I wanted to start with the known one, just to give you guys kind of an area to go off of so that you could feel some familiarity. This one's just going to be called the perfect square trinomial. Okay, and earlier you had, a situation where it's an x plus 1, x minus 1. Well, this is going to be a situation where instead you have, and we'll use a similar example, x plus 1, x plus 1. So the other one differed in signs, right? But they had the same values. This one's going to have the same values and same signs. It's actually going to be the same thing. This can also, by the way, on a test be written like this. So hopefully you can recognize this either way. All right, so it'll be written like this or like this. And if we were to FOIL this out, so remember you FOIL x times x is x squared. Outer would be x times 1 is plus 1x. Inner is that plus 1x again. Sorry, inner plus 1x. Last is 1 times 1. It's just 1. And then you'll get x squared plus 2x plus 1. All right. So this is a perfect square trinomial. I think I gave you guys an example of this, but I didn't want to introduce it because it doesn't really do you any good to memorize this until you get over to factoring here. Okay, I'm going to use the example they have in the book, but you're going to notice something very, very similar about these. So here's my example. And the example they have in the book is x squared plus 16x plus 64. Alright? X squared plus 16x plus 64, oh yeah, I'm sorry, equals 0. I keep forgetting that. But at the end there, remember the one difference is that we have equals some number, typically 0, for our purposes. Alright? And what you're going to notice is that you have this x squared and this 64. Okay? You're actually going to do something very similar to what I did over in your difference of perfect squares. Notice I just took the square root of x squared and the square root of 64, and I figured out my values were x and 8. What you're going to notice again is that your first and last values are perfect squares. X squared and 64 is exactly the same as the numbers that I just had. Alright, so x squared minus 64. In this case, I've got x squared and a positive 64, but what's inside is a 16x. So this is the major difference between what you just did and what we're about to do. Okay, that 16x is the weird part. And this serves as like a tester, essentially. This is how you know that it's going to be in this situation where it's just something times itself. Alright, it's this tester part. And what you're going to do is you're going to take the square root of both of these again. So let's go ahead and take the square, and I think last time I wrote it, yeah, so I wrote it out a little bigger. So let me go ahead and write it out bigger again so that I can show you guys what's going on. 16x plus 64 equals 0. Okay. And last time I went ahead and put my square root signs. So go ahead and square root those values that you know are perfect squares. Same thing, all right, same process. And what you're going to get out of this, and I did it in purple last time, you know that this is x and you know that this is 8. All right, so you have x and 8 again. So we'll just write those, x and 8. Remember, they're going to go in parentheses. And here's how you know that you're doing everything right. You're going to look at these last two numbers, these 8s, okay? Basically, the square root of this has to add up to this middle part. So what is the square root of 64? It is 8, all right? So 8 plus 8, does it equal 16? Does it equal your tester number here? In which case it does. If it does that, then you know that these are both plus signs. All right. In this case, they are both plus signs. They do not differ. So that is the major difference between difference of perfect squares and a perfect square trinomial. Hopefully on your notes you're able to compare these two and see the difference. All right. So, and I'm going to go ahead and show you all of these pages at the end of all this, but they really do have a lot in common. I'm not going to be able to get both of those on one screen. I could edit these in later. No, I'm not going to do that. In any case, compare your two pages. They should be almost exactly the same. I use virtually the same example for both. Alright? The only difference is that one's going to be x plus 8 twice, and the other one was x plus 8, x minus 8. So this is why this is a perfect square trinomial. The other one is a difference of perfect squares because it has different signs. Okay? It's not actually why, but if it helps you memorize, then so be it. All right, and then now we're going to talk about how to factor trinomials. This is the last part, and this is going to be the weirdest part. There are all sorts of exceptions and situations. Oh, I'm so sorry. Don't forget to pause this. Okay, so pause this. Feel free to copy down. And the next part is going to be the part that we practice the most. Factoring trinomials is probably the most important part. Okay, and let's see. It looks like I've been using blue as my base color for everything. So here's the example they have in the book. X squared plus 9x plus 20. Actually, wait. No, this doesn't work. I don't like this. Alright, So forget that. I'm sorry. This is factoring trinomials. Okay. I didn't have a title on this page, and I didn't like that because every other page has had a title. I kind of wanted them to all be matching, so that irked me. Um, Unfortunately, that wasn't planned, so I just wasted paper for no reason, really. But anywho, the example they give me again is going to be this, and I'm going to work off of this example for purposes of teaching. They gave me x squared plus 9x plus 20 equals 0. And this one's not going to fit in any of your other categories. So it is not a difference of perfect squares because it does not have just a binomial separated by a minus sign. Clearly, there are no minus signs, and it's not a binomial. It's a trinomial. There are 3 terms as opposed to 2, so it's definitely not this one. Okay, it's also not this one because remember, you need perfect squares on both ends. X squared is still a perfect square, but 20 is not a perfect square, so you can't use this one either. This is where factoring starts to be a little bit different, and this is actually the most important part and what you're tested on most, what you see recurring in most of mathematics. Okay? What you have to do is you have to take all of your factors of your C term. So, step 1, here's step 1. Take all factors of your C term, of C term. Alright, and keep in mind, these can be positive and negative. So I'm going to put this in parentheses. Can be positive, or negative. Okay? So, for example, 20, let's go ahead and break it down into every single factor it has. And it's going to be kind of a mess, but I don't particularly like doing this. But 20, I'm going to go ahead and break down 20. Alright? 20 is 1 and 20. It's also 2 and 10. It's also 4 and 5. And it's also 4, 5. Oh, that's it. Okay, cool. So these are all the factors. Keep in mind, this is a positive 20. So you have not only positive factors, but you could also have negative 1, negative 20, I'm sorry, negative 2, negative 10, and negative 4, negative 5. All of these are factor pairs for 20. That kind of goes all the way to the bottom. Okay. And what you're doing is you're going to add these together, and you're going to find out which one matches your middle term here. So when I add these together, one of them should equal a positive 9. So we'll go through and we'll do this. 20 plus 1. Again, you're just adding them together, okay? So I guess here, there's an addition sign. I'm not going to write this for all of them because typically you don't want to do that. That might actually confuse you, but for purposes of this example, 20 plus 1 is 21. Is 21 the same as 9? No, so that's definitely not it. 10 plus 2 is 12. Is that the same as 9? No, so you guys are... 4 plus 5 is 9. Okay, so we have it already. I'm going to do these just for example's sake. Negative 21, negative 12, and then negative 9. Again, we only have one of these that matches properly. It's this one right here, 4 and 5. So as soon as you get that, your problem is nearly done. Alright? Keep in mind, this only goes for factoring trinomials with x squared as a lead. If we don't have x squared as a lead, this changes out a little bit. Alright? So your second step, alright, is find your pair of factors that add up to b. That add up to b. Add your b term. Okay? As soon as you find those, all you're going to do is remember you have x squared, right? So this is always going to be x times x. To get x squared, it's always going to be x times x. So it's going to look something like this. So here's your third step. Alright? Your third step is going to be write your x's in 2 different parentheses. Remember, we're essentially getting it back to a FOIL format. It's going to be x plus something, x minus something, times x plus something, x minus something, something like that. And it's going to be just these 2 FOIL looking things, these binomials, okay? And how you figure out what goes in here is you take whatever numbers were here. We had a positive 4 and a positive 5. So we're just going to, not type in, sorry. We're going to write in a positive 4 and a positive 5. Okay, and that is how to factor, sorry, on screen, there we go. That's how to factor a trinomial. Okay, guys, that's this whole process. Let's go ahead and prove now. So feel free to pause here if you need to catch up on the notes. I'm going to go ahead and move on to the next page, and I'm going to prove to you that this is the same as that. All right, so on our new sheet of paper, we had blue is my leading color, x squared plus 9x plus 20 equals 0. And then you also have your binomials down here, x plus 4 and x plus 5. So just remember you had these x plus 4, x plus 5. We're going to put that on that page as well. X plus 4 and x plus 5. So this is how you can always check if your answer is right. I probably should have done that in a different color actually, but oh well. We're just going to go ahead and work this out. So let's go ahead and FOIL. X times x is x squared. Outer is x times 5 is plus 5x. Inner is 4 times x, 4x. And last is 4 times 5 is 20. So x squared plus 5x plus 4x plus 20 is equal to x squared plus 9x plus 20. You'll notice that that is the same as that. All right. So this is what I'm asking you for when you factor. I'm asking for you to go from a trinomial, typically, in these cases of difference of perfect squares, it's a little different. I'm asking you to go from a binomial. But again, that's why I said that's a flag. Like if you only see a binomial, most of the time it's probably this. So that's a big flag for you. In any case, I'm asking you to go from a trinomial, that thing that we created before, down to your two binomials. So we're going reverse. Instead of foiling and getting that, we're going backwards from that to here. Okay? Again, all of this has a purpose in mathematics, which we will go over, but that is how you check it. That's how you do factoring, and this is just an introduction. We're going to do higher level things with it very, very soon. Hopefully this all made sense. I do have 2 other factor videos that I made years ago. They follow a different curriculum and whatnot, so this is definitely closer to what you guys will be seeing, but you're welcome to look at the other videos if this one didn't make perfect sense. All right, I'm going to go ahead and do each of these on screen real quickly. Shouldn't take long. So there is intro to factoring. All right, feel free to pause and copy. There is perfect square trinomials. Feel free to pause and copy. There is difference of perfect squares. Feel free to pause and copy. And then the last one, factoring trinomials. All right, guys. So hopefully that all helped out. We're definitely going to cover this, so don't stress it. Let me know if you have any questions, and I will see you guys in the next video.